Welcome to this interesting world of remote triggered laboratories, and I am going to demonstrate you operation of a pilot plant from a remote location. I am sitting here in a studio of NITTR Chandigarh, and from where I am going to operate a plant which is there at College of Engineering Pune. If you see here, you will find, and if you go to portal.coepvlab.ac.in, which is the name of the portal from where you can operate the plant, you will find that there are various options available to you like virtual terminal unit, then you have virtual labs, simulator, intranet and internet, and then you have other things like intake olympiad and virtual labs. Now, out of that, if you click on to the virtual terminal unit, you will find that it will lead to this screen where you will find that there is a slot which is being booked for you, and of course, you have to book a slot. We will create the slot for you, and once you book that slot, what will happen is for that particular time for which you have booked a slot, the entire plant would be available to you. Under your control, that plant would be there. So, once you say that for example, I have shown here the boiler and heat exchanger and spray dryer plant, we have created slot for that. Such 13 pilot plants we have. So, 13 students parallelly can work on this facility. But the most important thing is you have to book a slot, and the reason for booking a slot is we have to check at our end whether all the facility is up and running. That is the only purpose of asking you to book a slot. 10 minutes before the commencement of the slot booking, you have to be logged in and be ready. Now, once you look at this, and if you click on to the heat exchanger, boiler and heat exchanger pilot plant, you will find you will go to this. Now, this particular thing is nothing but a control system which is going to operate this particular plant for you, and you have to develop the logic for that. When I say you have to develop a logic for that, means you need to know how that plant works. Now, from where will you get that information? If you go to these documents, the documents are available for you. You can upload some documents if you want to, you can download those documents, and you can add the course here. You can book a slot using this, you can book a slot, and you can find out whether your slot is available or not. After that, you will book slot and you will come here. But please keep it in mind that we will create a slot and then you will book a slot. Once you have booked the slot and understood how that plant is working, then there would be a challenging statement for you. Now, in the previous session, I was referring to a challenging statement, and what do I mean by that challenging statement is, for example, run a boiler so that you will get steam at 110 degrees Celsius. How that will work? So, you design your own control system, you design the logic, and for the simplicity, I have developed this logic in which what I have done is I have switched on the heater, because my problem statement is to raise the temperature of water so that it will become steam, and then that heater is there. Then what I am going to do is, in this particular case, when this is the temperature of the boiler drum, the hot water temperature, and then using a PID controller, I am going to operate the firing angle of the SCR. And the critical thing over here is, if you see here, is you can write a program, you can download from this library, you can take those blocks here, put them here, connect them properly, and after connecting them you have to compile your logic. If anything is wrong here in the logic, it will tell you that no, sorry, this cannot run, this particular boiler cannot run. If it is everything is all right, it will give you a message that the compilation is successful, then you can run it, you can download, and then what is available to you is this logic in run mode. And if you put it here a mimic, then you will find that here you will find that this is a live mimic which I am showing you. Now, here you will find there is sufficient water in the drum, the heater is currently off, the temperature is 65 degrees Celsius. Now, these are the live readings, it is changing, these are all live readings, and then the pressure will go on rising. There is a control valve which will operate, and because of that you will use this heat exchanger for controlling the outlet water temperature. That could be your another problem statement. So, this entire plant is available with you as a live mimic. So, the beauty of this plant is for each plant there is an IP camera connected which will take you to the plant. So, there would be an IP camera which is attached to the plant, and using this IP camera, the entire control of this IP camera would be given to you, and then there are default locations. If you want to see, you can click it and say go to that. So, slowly the camera would take you to the location where you can see the plant. Even if you are physically away from the plant, you will see how the plant will look like, and even using this PTZ control you can even go to various locations or various components which are being attached to this. For example, I want to go to a steam control valve, I can say go, and then the camera would take you to that particular location. So, this is important as far as this camera is concerned. Another thing over here is, this is where you can tune a PID controller so that the temperature can be controlled. So, if you look at here, the input is the temperature of the steam which you want to produce, that is your set point, and then using PID controller you are adjusting the firing angle of this SCR. And now what I am going to do is, I will start this, and so that the temperature will start rising, and here you will find that the heater would get switched on. Now, that red button has become green, it indicates that the temperature will start rising. But while the temperature start rising, there will be a control because of this PID controller. So, this PID controller is now working because the temperature, I will show you the configuration. You have to just right click that block, and after right clicking that block you will find all the configurable parameters. So, at present temperature is being kept at 60 degrees Celsius, and the temperature is slightly more than 60, and that is the reason PID controller is showing you that the SCR is not fired fully, it is just 18%. So, if I close this, you will find here temperature is 62 degrees Celsius, that means above. So, it is fired only for 18%. And now what is happening is, whenever you are looking at this, you will find the previous case which I was talking about. I want to check whether how that control valve, the first thing is how that control valve looks like. There are students in this country where in their curriculum of instrumentation and control it is mentioned that a pneumatically operated control valve study is given, but most of the time you will not find that they have seen even a control valve. Now, through this we are giving them an opportunity to not only see how control valve looks like, so there is no surprise when they enter in an industry that they have not seen those products, but we are giving them a chance to operate that control valve. For example, if I go here and give a command, I am sitting here away from the plant and I am giving here a command. So, I will right click here, I have configured this and I say that I want to open this control valve, and if I go here and keep on looking at how that control valve would operate, then I will come to know that slowly the control valve will open, and then I will find out that the command which I have given is now reaching to a control valve, the control valve is operating, and there would be effect of this operation on the position of this. You can see here now the control valve is moving up. So, now the control valve has opened fully. Now, this is important that the command which I have given or the logic which I have written is working properly, and because of that I get confidence that whatever logic I have developed here would work well. Now, there is one more aspect of this, and that is called as you can plot the trends. For example, I want to check how the temperature was there, what is the temperature, how it has gone, I can do that. And not only that, I can check the other parameters also using the trained facility which is available. For example, I can see all the temperatures, how they are moving, I can see how is the firing angle, I can see whether motor is working at what speed, everything I will come to know, and that is what is being plotted here. So, using this control valve, for example, now I have made this control valve open 100%. Now, if I close that control valve using a command and I say that I want to close this control valve, and I go back to this and check whether the operation is taking place or not, then once that is received by this, the control valve is closed. Now, if you go here, you will find that control valve is slowly going down, and this is the delay which you will have, and that is exactly the difference of remote triggered lab versus the lab which is actually triggered. But now just look at this, now the control valve is closing, right. So, you can see that the command which you have given for closing the control valve has reached to the control valve, and here you have seen that the control valve is closed. Now, that is how things will move, and that is what you will find here. Now, here FCV has come to 0, that means now the control valve is closed. Now, you can even think of going to the mimic again and check what is happening in the plant. So, you can see here, if the level in this drum goes down below a certain limit, this will be working like an interlock, and in my previous session I was referring to the safety of the plant. What is safety? Because I am at a remote location, I am operating a plant and nobody is there close to the plant. If anything goes wrong, either intentionally or unintentionally, your intention may not be damage the plant, but unintentionally, if something goes wrong, what do I do? How can I stop this? What is the safety? So, let me tell you, there are 3 levels of safety which we have configured here and implemented, and in fact, we give challenge to many of our students, those who are using these plants remotely, that even if you wish, you cannot damage the plant, because if you make a mistake in configuring, in writing the logic, it is all right, but we have 3 levels of safety. The first level of safety is related to the hard interlock, means we have physical temperature switches, pressure switches, and the safety valves connected, that if you do not take care, these switches will operate and they will stop the plant and make the plant safe. That is first level of safety. The second level of safety is related to the software which we have written. In that, even if you give a command, for example, here, if there is no water in the tank and still you have fired the heater, and if that level switch, hard level switch has not operated, and the logic which you have written, where you have not given a command or you have not written an interlock saying that if level in this tank goes below this low level switch, the heater will not switch on. If you miss that, still there is a master program which is there in our server, which keeps on checking such things which are critical. This is called as second level of safety, where the master program will check whether the safety command is violated or not. If it is violated, it will stop the plant, indicating you that you violated the safety. So, I have stopped the plant, and then you will come to know here that the plant has stopped. Now, the question here is, if suppose that also will not work, that means you have not written the correct logic as far as safety is concerned. The hardwired logic, which is physical in nature, is not working. The soft logic or the master logic which we have developed is not working. On top of that, we have a master command. On my mobile, I receive an emergency message indicating that so and so plant is unsafe, close the plant, giving me emergency stop operation on my mobile. So, wherever I am traveling, whenever I am carrying my mobile, and whenever somebody is booking the slot and using the plant, I will come to know that the safety is violated. I can simply press the switch and the plant stops. So, this is the last level of safety which we have, and that is why we are confident that even if you are away, you are not close to the plant, you have made some mistakes, there are certain hardware failures, still the plant will stop on its own. Now, important aspect of this, if you look at the mention here, you will find here some mention is there. So, for each user, we are giving them a challenge, and that is very, very important as far as energy conservation is concerned. We are giving them a challenge that here you will find that there is energy consumed when the plant is in remote lab. Here when I update this and when I take that as a challenge, at present I have taken the challenge as maintaining the temperature of steam, that is the challenge which I have. But if I take a challenge, that in the previous batch, and that is how the healthy competition will take place, in the previous batch they perform the experiment, similar experiment using 10 kW electrical energy. Can you do it in 8 kW? That is the challenge for you. Do whatever you wish to. You write your logic in such a fashion, that the consumption of energy will get reduced. So, that becomes your challenge. There could be another challenge where we will ask you that we want to check all the interlocks are working or not, all these interlocks whether they are working or not. You develop a logic which will test it is working. So, now what I am going to do is I am going to increase the set point of this, so that the temperature will go above 60 degrees Celsius. Currently it is 60, 30% means 60 degrees Celsius, because the range is 0 to 200 degrees Celsius of the RTD which we have used for measurement of temperature of the steam. So, now if I give this as 60, that means temperature can go up to 120 degrees Celsius. So, the temperature has to increase. Now, just check, if you have seen it properly, you will find that because now the current value is 62, expected value is 120, that means we need to fire the SCR to 100%. Now, the SCR is fired 100%, and if you can see here, you will find that this SCR is now 100%, which indicates that now the temperature has to rise. Now, I have to check. Now, this is where the intelligence comes into picture, that I have given a command, but physically whether that command is received at SCR or not, how do I check? So, that could be a question to that student, and then he has to identify, read this carefully and say yes, it was 61, now it has become 63, means temperature is rising, and this SCR is firing 100, means now the SCR is fully fired. You can see here temperature is increasing. As the temperature is increasing, as you know, temperature and pressure of a steam boiler will go hand in hand. Because of that, slowly this pressure gauge or the pressure transmitter will keep on showing you temperature going up. Now, for example, I want to have this picture once again, which shows me that whether temperature is increasing or not, whether pressure is increasing or not. At present the pressure will not increase because the temperature is just 66, means the water is just hot. But slowly when it goes too high, I am going to show you when the temperature goes high, slowly the pressure will go on increasing, right. But the wall is 100% open. We may ask the students that slowly what will happen, that this, just look at this, there is certain amount of fumes which are going out and I want to stop them. How can I stop that? Is I will give a command here and I will make it 0, alright. So, when it is 0, naturally what will happen is the temperature will start rising, naturally the pressure will start rising, and you will come to know and you will understand that how the graph would look like. And I want to show you after reaching that temperature how PID is behaving. I want to check whether the PID is behaving properly, just to test it. For example, I want to test it now. What I can do here is I will do one thing, I will play a trick here and I will say that the let us call this as 35 means 70 degrees Celsius as a set point. Just now we have to check how it works actually. Then you will find that whenever temperature goes above 70, you will find that the PID controller will take action. Just look at this. Now the PID has taken action and I want to check whether it is being seen here. Just look at this. The PID has taken action and now the PID has indicated or instructed SCR to fire less. That means the output here on this screen, if you check, the output here is showing 0, means now the firing has stopped. I can even check it once again whether PID is working or not, and I will do one thing. I will go slightly above and check how that is working. Every time whenever I am playing it, this is the beauty of this system. Now just look at this, and I will prefer that you should keep on observing the trend. Now just look at the trend. PID controller has now started taking action, but it has not gone to 100%, and the reason is the temperature which you are expecting and the actual temperature is just matching. That means it will just give heat to maintain the temperature, that is it, no more than that. So it has not gone to, just look at this, the PID is maintaining that, and because of that the SCR firing will not go to 100, it will remain here at 30, 34, and slowly you will find that if the temperature is still increasing, it will go down slowly to 0. So just look at the action. Now this is the learning as far as the remote triggered labs are concerned. As we are talking about remote triggered labs, we are also talking about utilizing those instruments. For example, the instruments or the pilot plants, if my students are not using, what is the use of the pilot plant if it is being kept idle? Nobody is using that. So anybody across the country can use these labs, take the advantage of having the pilot plants, and that is what I call that as a cooperative education system. So using that cooperative education system, you can build few plants instead of duplicating the plants which are available with us. What you can do is, you have a plant, your plant, I can use it, the plant which is there in College of Engineering Pune, you can use it, so that the utilization of the plant and the cost of the plant can be distributed amongst the institutions, those who are interested in this consortium. Now because of this, we can give very good facilities to our students without investing entire money out of it, and that is another advantage which I was talking about. The last point which I wanted to mention here is, because what is important here is just connecting these blocks, running a plant, can it give me guarantee or can it give me a confidence that a student who has cleared this test is capable of running a plant? How do I do that? How do I evaluate or assess that student would be a question for me always. So what is being done as far as this remote triggered labs are concerned is like this. Whenever the plant is running, whichever action is being taken by the student, every action and every parameter of this mimic, like level, temperature, pressure, flow, firing angle, running speed of the pump, all actions, all parameters are being logged at the back end in the data server available for the remote triggered lab every 500 millisecond. Every 500 millisecond, we make sure that the data is being stored and the file would be generated when you complete the experiment. When you complete the experiment, the entire file would be mailed to you, because we have your registered email ID, and using that registered email ID, it is possible for us to send you that file. What is important is, unlike the experiments which you were doing in the lab, taking 4-5 just 4-5 readings and making comment on taking 4-5 readings, instead of that, if I give you 1000 readings of all the parameters without investing your time which is required just to note down the readings, so that part of the experiment I have automated. By doing this, what has happened? Now the student can concentrate on more intelligent work than writing the readings. That is point number 1. Point number 2 is, once this Excel sheet is available to a student for analysis, then a teacher who is in charge of this lab, maybe in the same college or the college from where the student has logged in or booked a slot, can ask him questions, why temperature of this steam has gone up when your set point was x, why it has become maybe 0.1x or 2x, why. Whenever there is a discrepancy in the reading, there will be a question, and then once you have completed the experiment, maybe by booking a slot for 2 hours, maybe booking a slot for 1 hour, you can still continue working, and that is most important aspect of remote triggered laboratory. You can still continue working on the experiment for analysis of the data. Then when you have fully developed this logic, then you will come to know that I have developed the logic, it is running, but it is not satisfactory. Probably that would give somebody a chance for another challenging statement, saying that your peer or your friend has operated this plant like this, analyze the data, and analysis of the data itself become a huge task for that student. And after getting that, after doing this, how you want to control this plant in another. So, what is there is the challenge would be there, Excel sheet would be there, and the next important aspect is you can see the trends and mimic. So, if one student is working on the plant, what will be the role of other students? They can go in live and they can see what is happening in the plant. So, for example, I want to check, because now this plant is on, I get a chance, I go in view mode and I see what is happening here, just see here. So, entire data would be available here under the train to those students, those who are, I have just switched on this train. So, if I am a passive user of this system, I can see what is happening here, and then I can say, oh my God, temperature has gone above 80, still he has not taken any chance, and still the SCR is at 24%. So, that is the learning actually, that is the learning where he will say, or the student who is not operating the plant will keep it in mind that the firing angle should have been 0 actually, why 24, what is wrong here. So, for each and every parameter which you are logging in, the student, those who are observing, and any student who is registered in this portal can see what is happening even if he is not controlling the plant. So, that is another beauty of this type of a facility which is available. All put together, you will find these are the plants like flow loop, boiler heat exchanger, pressure, vacuum level, bottle filling, torque and vibration, batch process. So, most of the plants are quite interesting and challenging for the students, and these plants, through this project of virtual labs and remote triggered labs, thanks to Ministry of Education for supporting this, because of that the facility can be made available, and once the facility is available, it is made available to all the students, not to the students of College of Engineering Pune. So, any student who is having a background of automation can still use the lab. Now, once a student has completed the experiment, readings are there, mandatory requirement is he has to stop the plant. Now, the question is, suppose he has not stopped the plant, or because of some reason there is a network failure, the entire control would come to the master control which is there in PLC of COEP, and then after the time has elapsed, the plant will stop by the master control system, or a student is supposed to stop, but when he says stop, it is stopped successfully. So, he get a feel that yes, I have stopped the plant successfully, everything would go, indicating that now you have given control to the administrator of the plant, you are no more a user of this plant. Now, what has to happen is you can clear this, saying that now I want to stop this, and the job is over, and the student can now complete the experiment after booking a slot, get all the readings associated with that, and then what happens here is there would be some documents which will be given to him for reading. For example, I want to check which documents are there. So, few documents are here. So, here a teacher can upload the instruction, or a teacher can upload the challenging assignment for the student, because it is his login. If you see here, it is his login. So, you can upload. Now, the student can upload answer sheet, student can upload the video, that is most important. Means after completing the experiment, the evaluation can continue, and this can be done. A student can upload the answer sheet, he can view what is happening here and which course is there, how much time is there, which test is for me, and then he can select a test and he can appear for a test. So, the evaluation becomes very, very important, and that evaluation is based on the time available for a teacher. A teacher can be admin here. We normally give access to those teachers who are interested in using this facility. So, he can upload his question and ask the student that if you have performed the experiment, you conduct this or carry out this test and upload your answer sheet, so that I will understand how much is the understanding level of a student. Besides that, the Excel sheet which is available to a student will be made available to teacher also, so that the teacher can also access, get the dashboard and get the salient features of the experiment, and then he can comment on whether a student has done a good experiment or not, and then you can stop the experiment, and that is how you can use this facility. I just wanted to make you sure that this facility is available. Similar facilities need to be generated, need to be demonstrated and developed. All the technological hurdles which we had in the initial days, whether a critical plant can be operated remotely or not, if yes, how can it be operated, if there are issues related to server, if there are issues related to network, how the things will happen, what about the safety, what about the evaluation, all the questions which are related to performing the experiment are being addressed, are being solved, and here is the robust model of remote triggered laboratory is available for the country. Anybody who is interested in replicating or duplicating this is a public domain project, anybody can do that. Entire help would be available through the consortium as well as through College of Engineering, Pune. In the next version of it, when we are talking about remote triggered laboratory, in the next version of it, we will be talking about, and I will be demonstrating you a virtual laboratory where physical instruments are not part of it, only simulators would be there, but in those simulators also you will find that a nice evaluation framework is always part of it, so that the seriousness of performing experiment, even if a faculty is not there, is maintained. Now, that sanctity which we have to maintain of performing practicals and undertaking the exam, so that sanctity is maintained, but without policing. That is the most part of it. I will be demonstrating you next the virtual labs in instrumentation domain. Thank you so much.